Okay, hi. Today I want to tell you what is a tensor, basically, what a tensor is. So, I learned this from the Science Asylum and Eigen in particular. Eigen is one of the best channels in YouTube for this particular topic. So, what is the definition of a tensor? Rank n tensor in m dimensions is a mathematical object that has n indices and m raised to n components and obeys certain transformation rules. So we basically have understood that it is a mathematical object that obeys certain transformation rules, such as a change of component system should keep the whole thing invariant. So the word tensor comes from the Latin word for tensile stress, that is why it's tensor. So going on the stress trend, let us consider the stress tensor. If you consider a cube-like object, basically a cube, it can have translationary stresses in three directions. So we have three items in our whole tensor, and then we have shear. Based on if something shears, there are six more stresses that come into picture that are very unique and cannot be normalized into each other or something like that. The effect on the cube is unique, that's what it means. So what sort of tensor is this? So this is a three-dimensional tensor of rank 2. Why is it of rank 2? Because rank is the number of checks you need to find a specific component. A specific component can be obtained in two checks, row and column. So that's your rank. So this is the electromagnetic field tensor. It is of rank 2 and dimension 4. Now let's consider some basic concepts. A rank 0 tensor is a scalar. Rank 1 tensor is a vector. And rank 3 and rank 4, all of those and so on, it keeps on going. So Latin letters for rank 4 tensor can be represented with Greek letters T, alpha, beta, mu, nu, and Latin letters T, I, J, K for a rank 3 tensor. So now let's quickly grasp some tensor mathematics. So there are forward and backward transformations of coordinate systems. So just let's consider one basis vector like this and another basis vector like this. So one is EI vector, E1 vector, E2 vector, EI1 vector tilde and E2 vector tilde. So basically what we need is we need to transform from one coordinate space to the other. So how many so E1 tilde, what is it in terms of E1 and E2? Figure that out. Basically, if you do component analysis, you will figure that it's 2E1 plus 1E2, and E2 tilde similarly something else. You have to figure that out. So you get two matrices that pertain to the vector space with basis vectors. So if you multiply those two matrices between the forward and backward transformations, you get a identity matrix. So that I learned from Eigen. And if you carry this a little forward, you will see that here for n dimensions, Ei tilde is the summation of Fji Ej vector. Similarly for that, if you substitute one in the other, you get this. And when you think about it, when will that particular middle term be invariant? It will only be invariant when the diagonals are 1 and this particular condition is met. That it is 1 if I is equal to k and 0 if I not equal to k. So if I is equal to k, what will happen? E1 will be equal to E1, E2 will be equal to E2, E3 will be equal to E3, and so on. En will be equal to En. So you will get an n-dimensional identity matrix. So this is the Kronecker delta. It is a particular symbol. It is so unique that they gave it its own symbol. That is this condition. Do check out Eigen and Science Asylum for more knowledge.